Guten Morgen, Algebra 2, Herr Krieger here. Coming at you with lesson 2.1, beginning chapter 2, graphing quadratic functions. We're looking today in factored form, okay? Your task for today is to watch this video. If you really need to go to the kitchen and get some toothpicks to keep your eyes open, be my guest, hit pause, go grab them. And after the video is done, complete your your 2.1. Try it on your own assignment. So what we're looking at here, essential ideas, we're going to kind of look back to Algebra 1 and what the factored form of a quadratic function looked like, which was f of x equals some a value times x minus r1 standing for root 1 times x minus r2 standing for root 2. And given the factored form of a quadratic function, find the x-intercepts, which is real easy. The vertex, a little bit more work, not much. Axis of symmetry, super easy. And the y-intercept of the parabola, and sketch the graph. So warm-ups here, we're going to be working on factoring. Okay, the big key thing for today is going to be factoring. We will graph some today, but we're going to graph even more tomorrow. Recall, factoring quadratics. Remember, when we're taking factors of the first term here, which is 1 times 1, gives you an x squared, and then we have a whole list of factors of 40. We have 1 times 40. We could have 2 times 10. 3 doesn't go into 40. 2 times 10. 2 times 20. 3 doesn't go in there. 4 times 10. 5 times 8. Those are all my factors of 40. And then what I'm doing is I'm picking 2 factors and I'm guessing and checking and I'm putting them in here. Okay, now remember, this last term is negative. That's why these signs here are opposite. And when I multiply this little dirty dog back together, when I FOIL, or we call it double distribute here at WASOS, that I take x times x, I get x squared. And then I have x times 5 is plus 5x. And I take negative 8 times x gives me minus 8x minus 40. That when I combine my like terms, there's my first term, there's my last term. These two guys right here, if they end up giving me 5x minus 8x gives me negative 3x. That matched my middle term. That means I'm right. Main thing is just check the middle term, because we can quickly check if this is factored right. I know 2x times x is my first term, 2x squared. I know 3 times 9 gives me my positive 27. The key is, do my outside terms, my outer terms, 2x times 3, well, that's 6x. And my inner terms, 9 times x, that would be a positive 9x. Do they get put together, which would be 15x? Does that match the middle term? And if it does, that means you factored it correctly, okay? So that's what we're going to do. We're going to guess and check these a little bit. And what I'm going to look here is I have factors of 1 and 5. So I always typically take my trinomial and I'll make 2 sets of parentheses, okay? And I kind of do things. I'll look at the first term. How do I get x squared? It's an x times an x. And then the next thing I'll do is I'll look at this. What's the only way I can get a positive? When I take the last term times the last term, I have to have a positive number. So what signs have to be right here? What times what gives me a positive number? Well, it could be a positive times a positive gives me a positive. Okay, or a negative times a negative also gives me a positive, so I have 2 options. So when I have 2 options, when this last term is positive, did you know that that middle term shows the sign that goes between both of these, or goes inside each one of these parentheses? Well, if you didn't know that, you know that now, so I'm going to have a plus and a plus, okay? And then what I do is I grab any old factors here and put them anywhere I want, 1 and 5. And after I put them in, okay, I'm going to check my answer here now. As I go back and I check my answer. Remember, x times x, I already know that's x squared. Positive 5 times positive 1 is positive 5. I knew that. The goal is checking your outer terms. X times 5 is 5x. You check your inner terms. 1 times x is plus x. Do they get put together? That gives me 6x. As long as that matches your middle term, you're a winner, okay? So you might want to hit pause here quick and try the next couple. and then unpause, and I'm just going to keep on rolling here. And what I do is I list, I'm not going to list all these possible factors of 24, but I'll do it one more time. I'm going to list 24. We have 2 and 12. We have 3 and 8. We have 4 and 6. And I think that's all of them. And then from there, I make my parentheses. I look at my first term. The only way to get x squared is x times x. The only way to multiply two numbers, the two last terms, and get it to be negative, one has to be positive, one has to be negative. It's the only way that'll work. So when your last term's negative, your signs have to be opposite inside. Okay, I hope you remembered that. And then from there, what I'm going to do is I'm going to pick any factors in here, and I'm just going to put them in. Well, I'm going to think about this. Obviously, they need to be 5 units apart, so I'm going to put my 3 here and my 8 here, and I'm going to look at this because, see, a positive times a negative, this is going to be negative 8x, and this is going to give me positive 3x, so I can kind of tell I'm subtracting my outer and inner term, and I know that they have to subtract to give me negative 5x as per my middle term, so there we go, I got that one, okay? From there, you just start to figure this out, okay? And some people call it guessing and checking. The only way to multiply two numbers to get 2x squared would have to be a 2x times an x, okay? Only way to multiply two numbers and get a negative for that last term, one has to be a plus, one has to be a minus. I don't know if I got them in the right spot or not. All my factors are 21. Well, 1, 21, 3, 7. Even back here, I always personally start with the factors closest together, but I mentally did it and I saw it wouldn't work. So what I'm going to do is I'm going to take my 3 and my 7 and I'm going to put them in there any which way I want. So if I put a 7 here and I put a 3 here, okay? 2x, these first two always work. These last two always work because they're factors of it. But the kicker is, do my outer terms, 2x times negative 3, that's negative 6x. 7 times x gives me positive 7x. That gives me just plain x. Is that what I need in the middle? Absolutely not. So that makes me come back, and that makes me erase those. That means 7 couldn't go there, 3 couldn't go there. But as I'm moving across, if I put my 3 here and my 7 here, now what happens is I get 14x, negative 14x, plus 3x. When I put them together, what do I get? I get negative 11x, winner, winner, chicken dinner, okay? And I just cruise along like that. Here I had a difference of squares. That's a perfect square. That's a perfect square separated by a minus. That's called a difference of squares. Some people really like to look at this as 4x squared plus 0x minus 9 to get their middle term. So when they make their sets of parentheses here, how do I get 4x squared? I get that by 2x times 2x. And last term needs to be a minus, a plus, and a minus. Closest factors of 9, 3, and 3. All I really need to do is check my outer and inner terms here. That gives me a negative 6x. That gives me a positive 6x. That's a really poor x, I'm sorry. And that gives me a 0x. That's why there's no middle term right there. It's just really a pretty big waste of time to write that, okay? And then we're going to keep on, I think, trucking along. I think I got all that page out of there. We're going to move on to the next one. So what I want you to do here first is to factor. The key today is to be able to factor. So when I factor this little bugger, okay, I got an x times an x gives me my x squared. My last term needs to be positive. That means it's a positive times a positive to get a positive, or a negative times a negative to get a positive. But remember, when I said that last term's positive, the middle term tells me what the signs need to be. Somehow I got to get negatives in there. So both of these are going to be negatives. Okay. Then I also have 1 and 6, 2 and 3. Well, I can tell if I put a 2 and 3 in there, what am I going to get? If I put a 2 here and I put a 3 here, what's this going to come up as? Well, I don't know. What is it going to come up as? Minus 3x, minus 2x, negative 3 and negative 2 gives me negative 5. Woo-woo, that's it. I got it. So we're totally factored, but when we use the zero product property to solve for quadratic functions, then what we do is we take each factor, first one's x minus 2, we set it equal to 0 because that's going to find out what our solutions are, plus 2 plus 2. I don't know if you remember that, x equals 2. So one of my solutions is x equals 2, and the other one is taking the other factor of x minus 3 equals 0, solve that little bugger, and we get x equals 3. So my other solution's 3. Now just so you know, okay, just to remind you of what the zero product property is and why it works and how it works, is it says if I take this number 2 and I plug it in for x, so I have 2 minus 2, 2 minus 3, that has the equal 0. It's finding the magical number for x that when I multiply these two factors together, I get 0. Well, 0 times negative 1 equals 0. So I can see anytime this factor is 0 times I don't care what that one is, I always get a 0 over there. So that is going to be my solution. Okay, when I look at f, first rule of factoring, everybody's going to freak out. First rule of factoring, I haven't hit it because I forgot to say it, but you should always look for a greatest common factor. Is there a greatest common factor between these two numbers? Why, yes, there is. 2x. They each have a 2x, and if I retract, if I take 2x squared and I divide it by 2x, I get an x, and I want to divide it because if I take 2x times x, it comes right back to my 2x squared. What's left if I take 2x out of 6x? Or think 2x times what here gives me 6x, that would be a 3, okay, equals 0. I'm factored. I have one factor here, I have one factor here. After factored, I'm going to set each factor equal to 0. I'm going to use my zero product property to find out one solution 0. And I'm going to take my other factor, set it equal to 0, and I find out x actually equals negative 3, so my other solution is negative 3 on that. That's what the zero product property is. And what that does is, okay, when I act, whoa, what is this business back here when I put an x? What that does is, that should have been a 2. Come on, baby. That should have been a 2. It's really annoying me that it's a blue one now. Okay, come on. I want a red one. The 2, there we go. So when I actually took that 2, realistically, when I put 2 into the function right here, what it did is it outputted a 0, and that is an x-intercept. Okay, so that's why they're solutions. X-intercepts are actually solutions to equations, all right? So we're going to come along here. Now we're actually going to finally graph one, but in order to graph it, we're going to complete the table of values and graph the function. Name the x-intercepts, vertex, axis of symmetry, and y-intercept. I think we can do all that at the end. Let's complete our table. Well, this is saying find f of 3. Well, that means plug a 3 in everywhere for an x, and then simplify. Well, that gives me negative 1, and that's times 5. So this is going to output negative 5. Then next I'm going to find f of 2, which means plug a 2 in there. So I got 2 minus 4 times 2 plus 2. Well, 2 minus 4, that's negative 2. 2 plus 2 is 4. Negative 2 times 4 is negative 8. So that would output a negative 8. Then they want me to find f of 1. F of 1 is plug a 1 in there, okay? A lot of this is mental math. I'm writing it out for you. So that gives me a negative 2 times, am I getting a negative 2? No, it's not, because that's supposed to be a 4, which means that's a negative 3. Oh, that's bad. 3, negative 3 times 3 is negative 9. So that gives me the ordered pair negative 9. I need f of 0 now. Well, is it okay if I look in there? Now, I better 0 minus 4. And that gives me 0 plus 2. That gives me negative 4 times 2. That gives me negative 8. And then I got to put f of negative 1 in there yet, which means negative 1 minus 4, which means negative 1 plus 2, I think. Yes. That means this is -5 times 1 equals -5. And the cool thing is I can see symmetry in my table here. If you can't see symmetry, you're going to see the symmetry here in your graph. I'm going to come here and plot 1, 2, 3, 2, 4, 5. So I got a point here. And then I got 2, 5, -8 is going to be here. And then I got 1, -9. Then I get 0, -8. And then I get -1, -5. Okay, and I can connect those. I'm not going to connect those yet, but I can see portions of this. I can see my vertex, my low point. Vertex is always the low point of the high point, remember. My vertex is right here in the middle at 1, -9. And like I said, we can see the symmetry in the y values surrounding the vertex building up. Okay, so that means this value right here, the axis of symmetry, is the imaginary vertical line that you're going to be able to slice this. See how each dot is equidistant on both sides? And that's a vertical line, so it's x equals, and it would hit the x-axis at 1. So my axis of symmetry would be x equals 1 off of that graph. Okay. What are my x-intercepts? Well, let's come back and let's use because I can't see them, I didn't plot them. Let's use our zero product property here and say x minus 4 equals 0 when x equals 4. What that means is when I put a 4 into the function, I get out a 0, 4 over 4 up 0 for an x-intercept. And here I can see my other x-intercept, x plus 2 equals 0. I can see the other one's going to be -2. So that actually means when I put -2 into the function, it will output 0 for me. And that's going to put my -2 over here. What is the y-intercept? The y-intercept is always when x is 0. So when my x is 0, my y-intercept would be -8. So it would be 0, -8. And then from there, remember, these do not, because this isn't a linear function, it's a quadratic function. And it's quadratic because when I take term times term, I get an x squared. Okay, power of x is getting bigger. That means it's a curve. Means it's kind of swooping out and it's curving and it's growing up. And the other side curves and it grows up like that. We do not make V's as best, we try not to make V's out of these. They just grow like that and they go up, okay? So we'll come to the next page here. The x-intercepts of the parabolas, okay? They're also known as roots or zeros, okay? Roots or zeros, just another way to dictate an x-intercept. They could also be called solutions as well. They are the, they are the input values that result in an output value of 0. Y-intercepts, of course, like I said, you plug 0 into x, 0 in for x into the function, you calculate it, and the axis of symmetry, like I said before, is a vertical line that passes through the vertex and it divides the parabola into two symmetric halves, okay? So here we're going to explore. We're going to graph 3 problems here quick, okay? How we're going to graph them? We're going to first find the x-intercepts. After we find the x-intercepts, okay, then we're going to find the axis of symmetry. And once we find the axis of symmetry, we will locate the vertex. And now, once I find these 3 points, okay, these are the 3 most important points in a parabola. Therefore, I would be able to make a good sketch for that parabola with only 3 points. Notice back here, when I made this table of values, I made at least 5 points. Kind of like making a line. It takes 2 points to make a line, 3 to make it perfect. In my opinion, it takes 3 good points to make a parabola. Typically, it's 5 we would use from the vertex to see the symmetry coming on both sides. Otherwise, if I have 3 special points, went the wrong way, 3 very special points, the 2 x-intercepts or the x-intercepts of the vertex, I usually can make my parabola in a very nice fashion. Then we're going to check these and make sure we got all these. on Desmos. Okay, so in order to find the x-intercepts, we are going to use the zero product property. And essentially what that is it says once your function is in factored form, take all the factors that have an x in them, x minus 3, set them equal to 0 and solve. Now, I usually wouldn't do plus 3. I think my Algebra 2 extended kids should know if it's x minus 3, I add 3, and I'm usually just going to jump to 3. That means, because it's the zero product property finding that means when I plug in a 3, it will output a 0 for an x-intercept. My other one is going to be x plus 1 equals 0, so my other one would be negative 1, meaning when I put a negative 1 in, I get a 0 out. There's 2 points. I can plot those. I can say negative 1, 0, and I can also say 1, 2, 3, 0. Now notice, smack dab, another thing that's kind of cool is with your axis of symmetry, because these x-intercepts are at the same y value, there's always something that splits the seam between 2 points at the same y value. That is your axis of symmetry here, okay? Check that out. I could actually go and I could count 1 point in, 1 point in, 1 point in, 1 point in, and where I meet in the middle is my axis of symmetry, okay? Now, I'm not always going to count them like that because that's really kind of a, well, it's a good way sometimes, but there's a better way to do it in my opinion. And the better way to do it is the axis of symmetry. If I count in equidistant on both sides here, I'm actually finding the middle of these two numbers. And if I'm finding the middle of these two numbers, I can take x equals, if I take one x-intercept of 3 plus the other x-intercept of negative 1, if I average them, watch this, I get 2 over 2, I get 1. And check it out, x equals 1. That is my axis of symmetry. Really important, axis of symmetry, it's an invisible line, which means it has to be written as the equation of a line in your answer. X equals 1 has to be written. You can't say the axis of symmetry is 1 because it's going to get marked wrong. It's an equation of 1. The only point on this parabola that this parabola will ever have on the axis of symmetry is the vertex. So after I find the vertex, I plug it in, I Glade air freshen it. So now to find the vertex, I'm going to say, what is f of 1? F of 1 is 2 times 1 minus 3 times 1 plus 1, which is going to be 2 times negative 2 times 2, which is 2 times negative 2 is negative 4 times 2 is negative 8. So when I plug a 1 in, I get a negative 8 out. There's my vertex. So I'm going to say 1, check it out, negative 8. It is right smack dab on that axis of symmetry. And I'm going to connect those. I said they're not V's, but when they're skinny like that, they're hard not to make look like V's. And then what you're supposed to do in your homework and stuff is you're supposed to be verifying this graph on Desmos. So I'm going to pull up Desmos, and all you got to do is go to Desmos and say 2 times x minus 3, parenthesis, parenthesis, x plus 1, close parenthesis, there's my parabola. Now, here's my vertex. Where is it telling me? Ooh, I got my vertex right. It's 1, negative 8. That x-intercept, negative 1, 0, I believe is what we had. And the next one over here is 3, 0. And I believe that's what we had. And I'm pretty certain everybody can make a vertical line through here. Seeing it's 1, 8, it's going to go through 1. So we verified those points with Desmos. We're going to come on here. We're going to do the next 2 problems. I would encourage you to hit pause quick and then fast forward through these when you get there. But again, I'm going to do these all the same way. It's in factored form right now. So I'm going to say 3x equals 0. X equals 0. So that gives me an intercept of 0, 0. The other one is x minus 4 equals 0. So x has to equal 4. That means when I input a 4, I output a 0 using the zero product property. I can plot my x-intercepts. Okay, 1, 4. I can see where my axis of symmetry is, but my axis of symmetry, actually, if I take intercept plus intercept, divide them by 2, you get 4 over 2, I get 2. My axis of symmetry is x equals, not negative 2, Mr. Kruger, positive 2. That's a skanky 2. Let me get it out of there. And it's 2, okay? And I would draw my axis of symmetry. I usually like to do mine in red. And I say it's x equals 2. Beautiful. And then from there, as I'm going to find my vertex, because my vertex is on the axis of symmetry, that's my x value, I need to find what is f of 2. Well, that's going to be 3 times 2, 2 minus 4. Well, 3 times 2 is 6 times negative 2. That's going to give me negative 12. So it's going to be a 2, negative 12. Right there. Now, look at my graph. My graph only goes to 10. Let's make y scale is 2 units. That means every hatch where I'm going 2, 4, 6, negative 2. Those are all negative, okay? So when I graph this, it's going to distort my graph. 2, 4, 6, 8, 10, 12. And there's my vertex. I'm going to graph it up. I'm going to graph it up. You're going to check it on Desmos. Here, okay, yeah, you will get to the point using your zero product property when they're basic and it's just one x, there's no number tagged to the x. Yes, you will get there and you will look at that and you will say, oh, if I put a negative 2 into that first one, it's going to output a 0. And oh, if I put a positive 4 into that next one, it's going to output a 0. So I can put my negative 2, I can put my 4, I can find my axis of symmetry by taking intercept plus intercept divided by 2. It's 2 over 2 is 1. X equals 1. Let's see if I drew it between 1, right there at x equals 1. Yep, it's 3. Each dot is 3 units away. I kind of missed this one a little bit, but that's okay. So then after I find my axis of symmetry, I find my vertex. That's the x value of my vertex. So I find f of 1. Well, that's opposite of 1 plus 2, 1 minus 4. That's the opposite. 1 plus 2 is 3. Negative 3, that's negative 9, so that equals 9, so I say 1, 9, which is right up here, and I connect them as best as I can, down, and then from there, we're almost done. Factored form of a quadratic formula, that is how it's written. R1 and R2 are the x-intercepts and roots. Notice, no number on x. That's the only reason I can say it's R1 and R2 right now. Describe how to find the x value of the vertex in words. It's pretty simple. The x value will equal R1 plus R2 divided by 2. Okay? So it is find the average of the x-intercepts. It's finding the average of the x-intercepts, and this is also called the axis of symmetry. Okay? Describe in words how to find the y value of the vertex of the parabola. Well, how we're going to do that is plug the axis of symmetry value into function. Whoa, what does that mean? That means my function, I'm putting in my R1 plus my R2 divided by 2. That will output me my y value of vertex. Okay? This looks ugly. It's just a number. Okay? It's just a number. So from there, you've watched the video. Hopefully your eyes stayed open. Go complete your 2.1. Try it on your own assignment. Make sure you check it on Desmos and then also check it on It's Learning. The main part of today is to be able to put your equation in factored form so we can graph them like I just did more tomorrow. Have a good day.